Okay, so hopefully you can see the PDF. You in this assignment you will design and implement complete RISC processor, single cycle RISC processor. What do you mean by single cycle? We mean that it takes one clock cycle to execute every instruction. There is no instruction overlap. There is no overlapped execution. Very soon we will be taught pipeline processors, where you will find that instruction execution is overlapped. Here that is not the case. It is a single cycle processor, as Professor Bhattacharya has probably taught you in the class, following that principle. The entire instruction set architecture is shown in the small table. Okay, so this is a quite simple processor. As you would find that there are actually very few instructions. In total, I think there are 4 plus 2, 6. 6 plus 6, 12, 14, 18, there are about 22 instructions. The convention that the notation that has been used is a little different to the notation that you have seen in MIPS. In MIPS, the contents of a register and also the name of the register is shown using $. Here, the name of the register is shown as, if it is a source register, it is if there are two registers, one is called RS and the other is called RT, and the content of that is shown by putting parenthesis around the name of the register. Okay, so RS and RT. It is a 32-bit word size processors. The address line of the memory is also 32 bits. How many general purpose processors you want to have is up to you. It has not been mentioned. It is up to you to decide. I think nothing has been mentioned that how many general purpose registers you should have. You may have something like 20, 21, 22. There can be special purpose registers like stack pointer, program counter, etc. Okay, you can basically follow the type of convention that MIPS follows. That is fine, perfectly fine. There are some very interesting examples. There are some very interesting I shouldn't say example, some interesting observations about the instruction set that you have to suggest. At first look, it might seem that it is quite impossible to work with such a small instruction set. For example, if you look at the logic operations, ANDing and XORing are supported, but fundamental operation like OR is not supported. Okay. Similarly, in the arithmetic operations, complementation is supported, okay, but subtraction is not supported. So you might ask, is this, I mean, can I at all write any useful program with this restricted instruction set? The answer is yes, you can, because the instruction set has been well thought out so that some of the instructions which are absent, directly absent, they can be supported. For example, subtraction is basically addition. If you are going to subtract y from x, that is, you're going to want to calculate x minus y, you basically perform x plus y complement plus 1. Now notice that bitwise complement is available as an instruction. So y complement, bitwise complement is available. Add immediate is available. So you can add 1 with that. Okay, and finally you can add that with x to get x minus y. So similarly, OR can be implemented as an combination of ANDing and XORing. Anybody has any answer? How can we implement OR using AND and XOR? Two input OR using two input AND and XOR?
Yes, sir. Hello.
Yes.
Just a second. A or B is equals to A and B plus A or B.
Yeah, I think it is A and B XOR of A XOR B. So you first calculate A and B. You also calculate A XOR B. What is plus? Plus suddenly don't bring plus into the scenario. What do you mean by plus is an arithmetic operator? We are talking of pure Boolean operations. So A or B is A and B XOR of A XOR B. I think it is something like that. So anyways, it means you can implement. Okay, I mean you can implement it. It's not a problem. Another important feature of this instruction set, if you look at the meaning fields and the usage fields, can you tell me a striking difference with the way MIPS operates and this instruction set? A fundamental difference between the way MIPS operates and this instruction set. This instruction set in many of the instructions have a restriction. What is that?
The first register always gets updated.
Yes. So here you in MIPS you can take one operand in register 1, another operand in register 2, perform the operation and store the result in register 3, a third register. Here that most of the instructions do not work that way. Most of the instructions actually only update one of the source registers itself. This concept might seem strange to you. However, there are many processors historically which worked in this way. There was a concept called an accumulator, which was essentially a register in which the final result was updated. And you had to first copy one of the operand values into the accumulator. There was another register. Then you perform the operation and update the accumulator value. And then you again copy it back to whatever register you want. So only the accumulator register could participate in any arithmetic operation. So it was even more restricted. Okay. The other registers, they were not general purpose registers, like they could not take part in arbitrary arithmetic operations. Here at least every register can take part in arbitrary arithmetic operations, but the restriction is that the result updates one of the source registers itself. So there is as if a feedback inside the circuit which does it. That's fine. Then notice the branch instructions. There is a branch and link instruction. The branch and link instruction you have seen. Basically, it is similar to jump and link JAL instruction. So it performs two operations. One is it updates the 31. I think is by this it means that register number 31 is the register where the return address is stored. So that is one hint that has been given. So I would suggest just use 32 registers. There are some special purpose registers like assemblers, reserved, etc. in MIPS. If you want to make them general purpose, use that. but otherwise have return address register, program counter, etc. All of these standard registers. Okay. Now this assignment is 3 week long and it has 3 parts. Okay. The first part is the paper, pen and pencil paper based design. Okay. I mean, you have to design the processor, thought out the design, document it, and for the steps 1 to 4, I would suggest don't draw like ugly. I mean, for the diagrams, I mean, my suggestion is use some standard tool to draw this diagram. Okay, like LibreOffice Draw or something, or maybe MS Visio or anything, any good vector graphic software to draw nice circuit diagrams. If you think it is too much of trouble, then okay, then you draw it on using on paper and then take a photograph or do scan it and create a PDF. And but you must prepare a consolidated report, and that report don't prepare a handwritten report. Okay, I mean for the different steps 1, 2, 1, 2, 3 and 4. Just prepare a professional looking either LaTeX using LaTeX or using a standard word processing software like MS Word or LibreOffice, right? You prepare a proper report for steps 1, 2, 3 and 4. First, describe the instruction formats in that. Okay. Follow the instructions that have been given in the steps. For example, in step 1, in instruction for deciding the opcode, you should keep provisions for adding more instructions if necessary later on to the instruction set. Okay. Follow general principles like the opcodes of related instructions are similar to each other. There can be an function field and like the way MIPS does, that certain bit pattern show that this is an arithmetic operation, and then further some bit pattern show which operation it is. Okay, so you can follow those instructions, and this is a very simple instruction set, so you will have a lot of options. There is no particular requirement that you must follow this, just some suggestions that have a look at the way MIPS instructions are encoded and try to follow good instruction encoding practices. Identify the data path elements and draw an architecture for the arithmetic logic unit. Clearly differentiate between the data lines and control lines in your architecture diagram. For drawing this architecture diagram, you can have a look at your textbook, in which simple single cycle architectural diagrams have been given. Of course, there will be differences. In your textbook, it is basically represents the MIPS instruction set. Here, your instruction set is different from MIPS. The way it works is different from MIPS. So accordingly, your diagram should change. Don't just copy paste the diagram you have on your textbook and say this is also the same as my instruction set diagram. There should be a correspondence between your instruction set diagram and the actual instruction set that you are designing. And again, as I said, that if possible, draw it using a nice vector graphics drawing software. If you think that is going to be too much trouble, then okay, you draw it using on pen and paper and take a PDF scan. Finally, combine everything into a single report file which describes steps 1, 2, 3 and 4, or another way is you have 4 different PDF files which describes steps 1, 2, 3 and 4 and zip them into another folder. That's what I have actually mentioned in while uploading the assignment, that there is provision to upload exactly 2 files. Okay, one of them is a zipped folder corresponding to your solution for steps 1, 2, 3 and 4. How many files it will have is up to you. And finally, there are other zipped folder should contain the solutions for steps 5 and 6. Okay, all the source files, etc. There can be other subfolders inside your zip folder if you want to arrange it in a better hierarchical manner. No problem. Okay, then step 3 is draw the complete data path along with the control signals. So like the complete diagram, then write the truth table for the controller signals as a function of the opcode and the function code. Note that for a single cycle instrument in the implementation of the controller, there is no state and the design is purely combinational. Okay, so your design of the controller is very, very simple. You just write the truth table and encode that truth table in Verilog. Translate the truth table in Verilog. Your synthesis tool will take care of actually implementing the combinational logic. So you don't need to minimize the truth table or go through that painful procedure. Just describe the truth table. Then step 5 and step 6. Step 5 is actually the second major step. Step 5 and step 6 are the actual design Verilog, implementation of the circuit. The complete RTL has been given. They should have separate and modular codes for data path and control path. Okay. Your top level file is kgpregister.v. Then the other files are datapath.v, controller, register file, ALU, instruction memory, data memory, which there can be, you can instantiate other modules as you like inside the Verilog files. Everything should be in one folder and they should be part of the same project. You can give your own names also. This is fine. Okay. Now, number 6 is a relatively interesting and relatively challenging. So, along with the your entire thing, entire design in step 5, you may optionally add, and I would suggest you add a separate test bench to check your top level file like say kgpregister.v. Okay, so there should be a separate test bench file to check that the basic operations are working, at least 1 or 2 examples of each of the instructions that it is working. Step 6 is more complicated. Step 6 says, okay, you select a algorithm that you know. Okay. GCD computation or sorting of numbers, etc. Now you have done this type of assignments in your MIPS part of the course. Now the question is, this instruction set is not MIPS. Okay. Can you implement the same algorithm in using this instruction set? So there must be an assembly language description for this instruction set. That assembly language program will be now become a test bench, Verilog test bench. Okay, so earlier times when we had access to the actual lab in other years, actual lab and the actual hardware FPGA, students would save it, would write that code, save it in a hex format, and then there are methods by which that hex format file can be loaded into a portion of the inbuilt memory of the FPGA called BRAM, block RAM. And then from there, the processor module would take one instruction at every clock cycle and would execute it. And finally, you will get the result. That result would again stored back to block RAM. Then from there, it can again be transferred back to the PC. And then you can get your result. So this was what your students used to do. Now we do not have any access. Okay, so it will be fine if you basically perform a post-synthesis simulation of this design with, say, you write a program to compute GCD. Suppose that program takes 50 instructions. It might take less than 50, it might take more than 50. I don't know. I'm just giving an example. Just simple. So suppose it takes 50 instructions. So now your test bench would consist of basically every this collection of sequential instructions one after the other, which will be fed one after the other to the processor input.
Yeah. So,
and the processor will compute something, and finally that computed value you can print.
so one point that I would like to add, RSC here, that you also can use the block RAM. I mean, I think there is a component to design the memory. So you can actually do this at the simulation level also by using what is called as a COE file. So we will give you instructions as we proceed actually on how to, like develop the instruction memory and the data memory. So what you can also do is you can write that content as a COE file, okay, and your processor should be so it should be a part of the instruction memory, because the instruction memory, you can imagine that you can make it prefixed in this case. So you can write the what is called as a COE file, so that will give you the content of the block RAM, and that will comprise of all these sequence of instructions, like these 50 instructions that we, like 50 odd instructions that we will be needing for implementing a specific algorithm. So then after that, it will be a pure simulation, right, where you will be just reading from the block RAM, and your processor data path and your controller, right, should be sequencing with each other, operating with each other, and execute the algorithm.
Okay. So my suggestion is, you have 3 weeks to complete this. I have already given the deadline on Moodle. Set the deadline to the 12th November. It is not possible to be extended beyond 12 November, because 12 November, as per the academic calendar, is the last date of lab classes. It is mentioned. You can go and check on IIT website. So 12th November is a hard deadline. 12 November midnight is a hard deadline. There will be no extension this time. No extension will be possible. So you have exactly 3 weeks. My suggestion is, for parts 1 to 4, try to finish within 1 week. Okay, this is my suggestion. Once you have the design, and with the amount of exercises you have done in Verilog of different types of circuits, or with different types of arithmetic circuits, combinational circuits, lot of material has been given to you for in general about Verilog instruction. Okay, several sessions has been conducted. I don't think you will have too much trouble in translating your specification to the Verilog code. It will be relatively easy. This is please understand, this is a primarily combinational design, okay? And you can data the memory, etc. You can either model as block RAMs. Just look at the specification of what is a block RAM, or you can model as collection of registers. If you model as block RAM, it might help, because later on, as Professor DM said, that you can load your instructions in the block RAM, treat it as your instruction cache, and fetch, or instruction memory if you want to simplify, and fetch instructions from there, fetch data from data memory, which is another probably block RAM module, etc. So it will give a realistic kind of an scenario. But it is very important that you finish the specification correctly within 1 week. That is very important. So that is my suggestion.
So one thing that maybe we can do, and I would request particularly the students to participate in this, is that next Wednesday when we have our lab, we will ask randomly, groups about how you are, like handling problems 1 to 4. So you can, like share your screen, and you can tell that this is how you are planning the instruction set architecture, and this is maybe some other batch we will ask how you are planning the data path, and maybe some other batch on how you are planning the controller. Okay, so we will have a discussion on this, and as RSC mentioned, right, I mean, maybe this Wednesday and by next Friday, right, all of us should be kind of having a fair idea about how to handle problems 1 to 4. If you do that, then handling problem number 5 is much more simple, because here once you understand the overall components, right, essentially what problem number 5 tells you is to do the design in a modular fashion. Okay, so you have the top level diagram along with you by then, and then you know that, okay, these are my modules, and then you can go ahead and start developing those inner modules first actually. So for example, the register file you can start with probably, okay, and you can like represent implement maybe the the memory component after that. So for this, of course, like you will probably like while you are developing the Verilog code, you may have some specific queries that we will try to handle. For example, how do you handle the block RAM? Maybe we will try to give you a guideline on that. Okay, so I think Siddhartha, you are there, right, on the call? Siddhartha? Hello. Is Siddhartha there on the call? Okay, and the TA is there. I mean, I don't know.
Sir, I am here, Shomaditi.
Okay, Shomaditi, you are here. So maybe we can plan.
Also there.
Now, Coeli has a qualifier probably. Anyway, so I think what you should, what you should do is to try to prepare a small tutorial on how to handle the block RAM. Shomaditi. Okay, so discuss with Siddhartha, and we can plan that in one of the, maybe next Friday or so, basically. Okay.
Okay, so I will talk to Siddhartha, sir. Okay.
Yeah. And so basically what is extremely important for you, all of you, the students, is the, like problem 1 to 4, try to plan it out and come prepared next Wednesday so that our discussion is fruitful. Okay. Yeah. So any quick question?
Excuse me, sir.
Yeah.
So can you please confirm the deadline of the assignment?
As
12th
Professor
November.
12th is a hard deadline. Okay. But what we are trying to say is that let's make some inner deadlines so that we know that we are in sync and we are not getting delayed. Okay. 12 is the hard deadline, is the institute level deadline. So we cannot extend beyond that actually. That's what it says.
This time we cannot extend it. Okay. So one suggestion is
but we have three weeks. Okay, so that is not small actually. So if you plan properly, you can finish a significant portion of this, and if not the entire part.
Consider it to be a 3-part assignment. The first part is specification development. Second part is Verilog implementation. Third part is verification through a standard program. Okay. So these are the standard. I mean, this is a standard design flow for any type of hardware design also. First you decide the specification, then you implement, and then you verify. For each of these, you logically break it up into 3 portions, and for each of these, you spend 1 week. Set yourself internal hard deadlines of 1 week that I must finish the specification within 1 week. I must finish the design, complete implementation within the next week, and finally the entire assignment.
In fact, try to come prepared by next Wednesday on problems, the part 1 to 4. I mean, these are just paper and pencil thought exercise, right? So if you come prepared next week, then Wednesday, then we can also discuss few things in the class, and all of us can synchronize together, right? So come with a thought that you will be more or less done by Wednesday, so that we can finalize it, and definitely all of us finish by next week. Okay.
Yes, sir. Yes, sir. And so one more thing, can you please update us on the previous assignments?
What do you mean? Like you want to say the grades?
Yeah, like there have been 6 assignments and 1 test.
Which assignment you were talking about?
Sir, we have been given 6 assignments and 1 test till now in
Right.
in computer architecture labs, and we have been graded for 2 Verilog assignments and 2 MIPS assignment, if I remember correctly.
Yeah, so 1 MIPS assignment and 1 test on the MIPS, they are pending, right?
And 1 Verilog as well, I guess.
Yeah,
yes.
In between there was the holiday, so now it will all be done.
Yeah, so we will give you an update.
Like you had holidays, TAs also had holidays, we also had holidays.
Yeah, that.
We will give you updates by next week.
Time, the MIPS assignment and the MIPS test results will be provided. You will get them next week.
So right now, focus on this problem. Okay, so there are, if we are properly doing this, then I believe that at the end of the day, when everything works, it is a quite enjoyable thing to see that you have your own toy processor and you are able to execute it. So hope that you will be doing these steps so that we eventually see the final output. So those batches which normally finishes the entire exercise, I find they quite enjoy. And by the way, try to write the Verilog code in a suitable manner so that you do not write it, like with non-synthesizable components. Then, as RSC was mentioning, when you do, like post route and all these things, then it will fail. So don't write your Verilog code, like a C code that I've told you at the beginning also. So try to write it in a synthesizable manner. That means think the hardware and then write your Verilog code. And therefore, it is heavily encouraged that you draw proper paper and pencil designs. Then the translation will be much more clean. Okay.
Got it.
Okay then. I think more or less we are done for right. Sarasi on HD.
Any questions, students? Any further questions?
So come prepared next week so that we will have an interactive session. Okay.
Yeah. Okay.
Sir, I just wanted to intimate one more thing. Like next week, there is a batch for students that are going to campus. Like the pre-final years have been called back, few of them.
Yeah. So that is, I believe that the administration will contact you, or if they have not contacted you, they will contact you. Okay. So
No. I was saying like that. Like, is there any relaxation? Like, if we aren't able to attend the class or something?
No. Are you traveling?
Yes, sir.
See, the chances that you would be traveling on both Wednesday and Friday is very small, right? So
Yeah.
if
Like I'll be traveling
somebody
on
cannot,
Wednesday.
if somebody cannot present it on Wednesday because of traveling, his or her partner will present. If none of them can present, or they want to present it together, then present it on Friday. At least one of the days you should be there.
Yeah, I mean, this is not like something that we are taking an exam or something else. Like it's more of like
So
your
there is
understanding. Yeah.
Yeah.
It's like, but
Yeah,
that,
also-
but you're
also
encouraged.
when
But you're encouraged heavily, because if you encourage, then it will become much more easy for you.
Yes,
Okay.
yes. I mean, this is from experience actually, that if you just show your design to the teachers and take their approval before going on to the actual Verilog coding, it helps. This is from our previous batch experiences. Okay. And another thing, when do you want to give your second lab test? 2 weeks from now, is that fine? Second lab test would be only entirely on Verilog, okay?
There is a window for tests given in the academic calendar, if it can be during that
Okay,
time.
so when is that? I think it's November 1st week probably, right?
So that's 15th
No, sir.
November
It's
to
15 to 20.
yes.
15 to 20 November.
Yes,
That will be for theory tests. That is not for lab tests. How can there be a lab test if the academic calendar says all lab activities must end by 12 November?
yes.
We have to
1 week
submit the
that
grades
should be
or
okay.
everything by. So DM and HD, what to do?
Just can we decide among ourselves, and then maybe we can tell you.
Yeah. I mean, 2 weeks. My suggestion is 2 weeks from now. Okay. Today is Friday, so 2 weeks from now would be 5th November. That is my suggestion.
So, but like after Diwali.
4th November is Diwali, I think, right?
Yes,
The
sir.
holiday
So
is
fifth,
on 4th November. 5th November is not a holiday. I'll check. Yes, for 5th November is not a holiday. 4th November is the holiday. So the day after Diwali, okay?
And so could you also tell us what kind of questions we'll get? Will it be similar to the MIPS assignment?
Yes, similar, and we will give you assignment, of course, problem which can be solved in 2.5 hours or 3 hours or whatever.
So basically we'll get
Whatever is the
programming
exam
questions only, right? Programming questions in Verilog.
Okay, it will be a problem which is solvable in that exam.
Okay, sir. Understood.
Then instead of 5th, could we do it on 12th so that it would be close to the test week also?
Sorry, I kind of lost connection. What do you have to do for Intel workshop, and will that be graded? So you can take part in the competition. Linking it to grades, I'll discuss. We have not yet discussed actually among the other teachers. We'll discuss and grade back to you. Okay.
sir, can the test be on 10th or 12th? Like,
Yes, sir. 12th seems like a.
Yes, sir. 12th would be fine because it would be closer to the test week also.
Yes, my only concern is 12th is also the deadline to submit this. So some groups, some of you might have will be doing last minute working, like doing the last minute stuff on this assignment. So will that be a problem? I mean, towards the 10th or 12th, you will be working like frantically on solving this assignment. I mean, at least those groups which have not yet solved it completely. Okay, so that's my concern actually. That's why I did not say 12th. Otherwise, I would have said 12th. So say some student groups say, sir, we are working on this assignment. I mean, if we now sit for the test, we will get distracted and we will lose time. So can we give the exam another time? That won't be possible, right? I mean, we cannot have 2 exams. So having an exam on the last day, then the other option is we bring forward the deadline of this. We bring forward the deadline of this assignment to 5th November. 5th, yeah, and
can
you
have
give
a
the test on 12th November.
excuse me, sir.
Rajat, the last day is 20th, right?
Last day is 12th for lab.
So maybe we can push the deadline by a single day, not by much, only a single day, so that it does not clash with the test date.
So the deadline to 13th, you are saying?
Yes, sir.
Yes, sir, that would be fine.
So that would be helpful in both the ways, even in the test and the word assignment.
Okay, let us teachers discuss. We'll get back to you. Anyway, it is 3 weeks. I mean, from now. So. Okay, fine. You don't want to give the test on 12th. It is understood. On 5th, it is understood. What to do with the deadline for this assignment? We'll decide. See, so let us have the test on 12th. What will be the assignment deadline? Whether it will be 13th or 10th, we will decide. We will decide.
All right, sir.
Okay, so the test will be on 12th. I will send out an email to all
I think,
students.
Rajat, just saying, let's have the test on 12th and assignment deadline is up to 13th.
Okay, fine. Yeah, I was slightly uneasy because of the official. Anyways, no problem. Okay. Okay, I'll extend it till 13 then.
Yeah, because last date for all labs is 12, but last date for all anyway. I mean, we are giving 1 day extra for the lab assignment. Last assignment, I think it's okay.
Okay. So great. I mean, the Intel lab thing, actually Intel, they are very interested in seeing that this becomes part of the official curriculum.
No, that we cannot do right now because.
But yeah, I mean, some part of the grade, but yeah, I mean, we can take a call on that. Probably we won't do it, but I would encourage you, because they have opened the competition window open starting from maybe yesterday till it will be open for some time. How much time has they given for the competition?
One month.
I would suggest try to do something on that, because they are giving good prizes and it will be good. I mean,
see, I mean, I can tell you the reason why we had it. It was just to give you an idea what are the latest architectural platforms and what are the latest programming practices for such platforms. I think it was a very nice exposure. So, of course, it is not right now. We will not make it a part of regular assignments. You can do it as a good programming practice for a new language, which helps you to, I mean, interact with these modern complex architectures. I mean, having such a thing on your CV, on your resume, may be a good thing.
Yeah, on a resume it will look good actually. I mean, this concept that there is a kind of a push button infrastructure to perform heterogeneous computing. From a Linux command prompt, you can compile a C++. I mean, of course, a specially engineered C++ code, but you can compile it and that gets automatically transformed to Verilog and then mapped to FPGAs. That is something quite amazing, right? I mean, this is not something that we are exposed to quite often in our curriculum. We just wanted to give you an exposure that such technologies exist.
Right. I mean, we paved the way for you to interact with them. Now, if you do that, maybe we will give you an appreciation certificate, something that can help you. Right now, we will not make this part of our evaluation or thing for the lab.
Yes.
It is basically a competition where you participate. They will give you a certificate or appreciation or whatever. We don't know. I mean, they will have things written in their website and all that, right? So, I mean, it may be a good thing for your resume. You can decide and take part in.
Many of you take part in online programming competitions also, though that is not part of the curriculum, right? You just take it, I mean, do it out of your own interest and passion and to enhance your resume. So similar, you can treat this similarly, okay? But online competition, programming competitions probably do not use this type of an technology, right? So a cloud-based heterogeneous computing technology, that is something quite unusual. And these things will become mainstream. I mean, as time goes by, that much we can, I mean, you can be certain of that this is not a niche technology which is just going to die out within a few years. Cloud computing and FPGA based computing are increasing day by day. I mean, in high performance domains, high performance computing domains, like real-time image search, etc., that happens on like on the internet that you do using search engines like Google. They all of them use highly specialized deep neural network implementations on FPGAs. Okay, so it's not something niche, and this technology, what that workshop showed is, you do not need to bother yourself about the nitty-gritty details of the hardware implementation. Your high-level synthesis tool will take care of that, and it will come up with a correct by construction Verilog. Okay, so hand coding of Verilog is not, hand coding of these architectures on FPGAs using Verilog is not necessary. That will be taken care of by the tools that they have. Okay, so that is something quite outstanding, right? I mean, Yeah, okay, so that's it. So let us meet on Wednesday. We hope that most of the groups among you will be done I would have completed steps 1 to 4, and you can project your screens and we can have a look at what you have done. And let us have the test exam on 12th November then, the last day of lab class. I have extended the deadline till 13th, so it's okay. Okay. Okay, thank you.
One last query. Regarding the implementation part. So till now in Verilog we have worked with flip-flops for storing data, but however this assignment will require us proper like sequential storage, like for anything, say registers for storing the instructions or the data memory also. So how
data
are
memory,
all
as I said, it can either be modeled as collection of flip-flops, or better you try to instantiate the BRAM module. The BRAM are Xilinx specific hardware instances. Okay, but you can directly instantiate them, BRAM, block RAM. Okay, so have a look at the manuals, and otherwise, as Professor DM said, on Wednesday we'll try to give you a small tutorial on how to instantiate BRAMs directly in your code and how to use them in your designs. Yeah, and for the registers, your registers are one-dimensional flip-flop arrays basically. So if it's a 30, it is given that these are 32-bit, this is a 32-bit design. So registers, each register would consist of 32 flip-flops.
all right, sir.
Okay. Okay. Okay, students, take care, and we'll see you on Wednesday then. And start working. Okay, this is an assignment which you should not keep pending till the last moment, because this is a step-by-step assignment. In your last moment, if you keep it pending, that 3 weeks is a lot of time, I will do it before 3 weeks. That for this particular assignment it will be difficult. For a monolithic assignment which just requires you to write one single Verilog module or one single MIPS program, that is okay. Maybe that way you can survive. But this one is difficult, because unless your first step of design is correct, you cannot start with the next step of doing the Verilog implementation. So your specification and design must be very thoroughly correct. Okay. Okay. Bye. Take care. Bye.